You'll notice other render engines boast a faster time, but they all have a single light based on a sun. Like here in the examples of Irray and Furry Ball. To replicate this speed setup with Vray, we have an example here which uses a ball and a plane, and I have a camera with the physical Vray attribute turned on under the extra attributes. This can be found under Attributes, Vray, and Physical Camera. We also have an image-based lighting node, which just has a picture of a black background with a white dot on it. And in addition, we're also using a Vray sun and sky. I have this special rig set up so that all of them move together as one. We're going to go back to this render view I have set up here, because today we're talking about global illumination. You can find the physical sun and sky under the Vray tab in the Vray physical sun and sky. If we go ahead and render our first render, we'll notice that it only takes about a second. This is using both of our lights, the IBL and the physical sun and sky. I like the IBL because it gives me a nice smooth shadow. The reason this physical sun has a smooth shadow is because the size multiplier is turned up to 20. If we turn off the physical sun and sky and render with just the IBL node, you'll see that they're pretty much exactly the same. A single light with a pre-calculated ray traced function. If we switch between them and turn the IBL node off and the physical sun on, you'll see that the result is pretty much the same. Either one of these lights will work for your speed render. But today we're talking about global illumination, so we'll turn our global illumination on in the global illumination tab and enable both of our lights for this test and re-render. You can see now that the ball has light which has bounced up off the plane, illuminating the back side of it. And if we switch over to our physical camera, it gives us a much smoother render, but the time is fairly much the same. And these are real-time renders, by the way. If we go into our history and use our A-B comparison, then we'll instantly see the difference between the global illumination and a picture without global illumination. Where the global illumination lights the backside of the ball, the picture without global illumination does not. So, most often, when working with a scene, we have multiple lights. So this is best described in space, like these trench lights, these hangar lights, the engine exhaust, or the ambient light, the light from the mechanical pieces, or the dash lights. Also, we have marker lights. Not to be forgotten are laser lights and dome lights, and of course, stars. You can't render this many lights with a speed renderer. Today, we're using this simple scene with a single camera move. This is the same scene that I used for my Ableton video. We go into our render settings. I'm using a multi-channel EXR and we're rendering at 4K today. If you go into Edit and change Project Image Directory, you can see that our image is going to the network drive, but our disk cache seems to be going nowhere. If we look at the file path, we'll see that it is also on the networked drive. The way to ensure that our particle cache, or in this case light cache, goes where we want, we can check in the Windows Settings and Preferences, and go down to Files and Projects. And we can see that our default project directory, in this case, is set up on our network drive. The network drive is just a mirrored image of this shared drive, which is called Project E, and I have it mapped to a network drive so that it's available to all the servers on the network. Now that we have our file paths set, we're going to go to our global illumination and change it to Irradiance mapping. The settings I'm using here were originally designed at Cornell for the Linde.com tutorials. The way that the Irradiance map works is it calculates a map for the light path and then uses it later in an animation render of multiple frames. So we're setting up our save path file here for our light cache. I'm going to call it IR map and save it in the particles folder. You can see right now that there is in fact not a cache. But if we save it, we can direct it to the network drive particles folder as well. We will also call this cache file IR map as well. If we go back, we'll see that it is in fact saved. Since we're using an animation, I have Use Camera Path and Multiframe Incremental turned on. Up to the dual screen setup, I already turned on my network nodes. My mouse is kind of wacky, but I'm just going through my settings, checking to see that all my settings are correct. I have animation turned off, and my global illumination turned on, as well as my distributed rendering turned on in the settings tab. I'm moving it to frame 20 because I want to get the stars into my Irradiance map cache. Then we're going to start our render on camera 1. You can see that it goes through and it creates what looks like a photon map. But it's not just for a single frame, it's the photon map for the entire animation. Then it will go through and perform the render. This is taking longer than usual because I'm using the render elements multiple layers. As soon as this finishes rendering, I'll show you that I have about 8 different layers on my EXR multilayer. So Maya is doing the calculations for not only the master beauty layer, but also the alpha channel, several different light passes, a whole light pass, a multi-matte, a Z-depth channel. Some of these I didn't tune very well. Then we have the ambient occlusion and last the vector pass. All of these were calculated during that render. And if we go to our folder, we can now save our cached Irradiance map. I'm saving it in the same cache folder on the network drive that we originally set up earlier. Under the mode, it now has samples and bytes and megabits of memory that it uses. Now we're going to switch over to a different global illumination engine, the light cache. You'll notice that we also have the Use Camera Path selected and the fly-through as the mode. It's similar to the Irradiance map in that it creates a light cache for an animation and saves it on the network folder before doing a complete animation. We're going to set it up the same way that we set up the Irradiance map. First, going to the render end and creating an autosave file and saving it in the network drive in the particles cache folder. It calculates the photons first and then performs the render. It seems that the light cache renders a lot faster than the Irradiance map. But if we go to our history and we compare the two, the differences are instantly noticeable using the light cache for a primary bounce engine. Again, we're going to turn on our A-B comparison, comparing A and B with the light cache in the Irradiance map. If we zoom in closer on this 4K image, we can notice immediately that the light cache does not have the sharp detail that the Irradiance map does, even though the samples are set up in 2000. It also seems to be blurring the ambient light coming off the windows. If we look here at the bridge, we'll see that there is no definition on the edges whatsoever. So light cache would not work as a primary engine in this case. Next, we're going to use both a primary and secondary engine after saving our cache file under mode. Again, naming it and saving it on the network drive in the particles cache folder. So we're going to set Irradiance mapping as our primary engine and light cache as our secondary bounce. We still have the same settings that we used before, and the cache files are still loaded. See, for both the Irradiance map and the light cache, both of them still have the cache files for our animation. They're loaded almost instantaneously since the computer doesn't have to calculate them again. You'll notice that now that the light caches are cached, that the render is a lot faster. As we do our comparison here from the history, you'll notice that our first Irradiance map took an hour and 8 minutes, while our light cache took 2 minutes and 48 seconds, but the combination with the cached files only took 12 minutes for a 4K render with multiple layers. You can also see that the secondary bounce gives us nice clean edges as well as ambient light coming off of our secondary lights. Now that we have our global illumination solution prepared and saved on the network drive, we're going to set up our batch render. First, I'm writing out my batch file longhand using this previous batch file that I used before. It's split up into several parts. First is the render sequence. Render start 1 by frame 1, end 29, and then it has the camera 1. The render directory is on the network drive under the tut folder. I'm going to add a subfolder and call it IRM. And last, we have the directory of the scene, which is also on the network drive. Once we have it completed, we're going to save it also on the network drive so it's available to all of our network nodes. Selecting the network shared drive off of the list, going down, we're going to change from our text document to all files and save it on this previous generic file right here. When setting up a network render, we want to make sure that every computer on the network has access to the batch file. This will become apparent in a moment. As we navigate to our network drive on our first slave node, and we scroll down, we'll drag and drop our new batch file into our notepad, we're going to change the frames from 1 through 29 to 30 through 58. I did this calculation earlier, and 200 divided by 7 is 29 frames. So for our second slave node, we're going to change the render from 30 to 58. Then we're saving our batch file on the desktop of our slave node, not the network drive. We change it again to all files. We'll notice we have a previous generic file on the desktop. We will save our batch file here. We have to go through this process again for each one of our network nodes. In this case, I'm only using 6 network nodes, but we have to update the file for each one, changing the frame range. Some people like to use programs like Deadline, but I find that doing it longhand usually works faster than using a secondary program. Then we have to go through and start each of the batch programs on each network node manually. This way we can render 7 frames simultaneously instead of rendering 1 frame at a time. After I've completed uploading all of my batch render nodes, I realized that I had forgot to change a setting in my Maya file. By opening up the Render tab, I noticed that I forgot to turn off my distributed rendering, so each batch file is trying to use every computer on the network. Now that I have changed the setting, I have to close down all of the batch files, also turning off the distributed rendering slave node, and repeating the process on each of the 6 network nodes. Once the network has been shut down, then I save my scene with the new settings distributed rendering off, and once again start up the batch render nodes. I've changed the layout of my render desktop so that I can see when the batch nodes turn off. This way I can adjust the batch files if one of them finishes rendering before the others. After letting it run for a while, I see that it's not running as fast as the distributed rendering was. The reason for this is because if we look at the render node, I need to upgrade it because it only has 8 gigabytes of RAM, whereas the workstation is using around 30 gigabytes of RAM to render this scene. Therefore, the batch nodes are taking about 1 hour as opposed to 12 minutes on the distributed rendering. So I'm changing my desktop back to the distributed rendering format, turning on the render slaves and turning the batch nodes off. Next, I go to my render elements and turn Use Distributed Rendering back on, checking the Animation tab and turning Animation 1 through 200 on in the Vray Common tab, checking my GI solution to make sure that it's still loaded, that it still has the cache files loaded, and then we start our render again. Making sure to select Camera 1 on the Render View node. It goes through and checks each file before starting the render, each frame. And I notice something is wrong immediately during the debugging process. It doesn't seem to be sending the files to my network folder. So once again, after nearly 14 hours, I have to stop my render again. It seems that I forgot to update my project work directory. Once I've given it the proper path, under the Edit, Change Project Directory Settings, sending it to the SWV folder in the network drive, under the master layer folder, then I can start the render again. After we get our first render back, then we check in the network folder to make sure that our image is going to the proper directory. I changed the settings from large icons to list. For some reason, I'm getting this warning: scene bounding box is too large. Although the scene is large, I usually don't get this error. While we're noticing that we have a frame rendering time of around 15 minutes, if we multiply that by minutes, it looks that our 200 frames are going to take a little over 2 days to render. So all of this debugging is not a waste when looking at a 48-hour project.